Hi, my name is Yvonne Roberts, and I'm a software architect at Build.com and a freshly minted AWS serverless hero. Today, I'm going to talk to you about productizing your serverless MVP. So before we get started, let's level set, right? What is the minimum viable product? If you search the interwebs, you'll find a couple different references. This one from Techopedia. A minimum viable product is a version of a product with just enough features to be usable by early customers who can provide feedback for future product development. And so the value of an MVP is it lets you fail fast, right? It lets you see, are you building exactly what you need to build for your end users? And it lets you have an opportunity to get feedback from those customers, right? Is what you're thinking really what they're looking for? So I'll tell you a little bit about an MVP that I worked on, and it was an identity credential microservice, right? And it had to support username and password, MFA, resetting those credentials, making changes, etc., right? On paper, it sounds very simple, but if you looked at the spec rec, I mean, the amount of requirements and features that it had were a long list, right? And so one of the responsibilities that I had was saying, okay, how long is this going to take us to release? What do we need to do to make sure that end users are happy with it? And what trade-offs can we make, right? And so what I did was I stepped back. I talked to all the consumers and said, okay, this is that minimum viable product. They need to be able to create username and password on day one. However, on day one, they probably don't need to reset their password or reset their MFA. So I was able to negotiate and say, you know what, that feature will implement it in 2 weeks or a certain amount of time, right? And I was able to take that product from an idea into an MVP, into a fully featured productized microservice within a good 6 months period and be able to, at the end of the day, deliver exactly what the customer wanted and needed. So that MVP, when you're designing it, whatever you've implemented today, what is missing, right? So like I mentioned, it could be missing product features. You might have cut a couple corners in coding best standards. You might have manually created some resources in AWS, or you might have over provisioned your capacity, right? There's a lot of different things, corners that you can take to be able to get out the door faster. And there's nothing wrong with that. You just need to have a plan to address those. So you built the MVP, you're in production, now what do you do? In this talk, we'll go over development considerations that you should make, security, deployment, observability, disaster recovery, and then I'll demo a microservice that I have created with a lot of these bells and whistles to facilitate productizing your serverless MVP. All right, so development. How do you design your application to be able to productize it, to be able to build on it quickly and seamlessly? The first step as we look at this is how do you organize your code? Alistair Cockburn has a quote that, both user side and server side problems are actually caused by the same error in design and programming. It's that entanglement between business logic and interaction with external entities, right? And so that organization, if we can create perfect boundaries, well, not perfect, but if we can create good boundaries, right? And have loosely coupled components and clean code, we can all build on that and you can productize your microservice with little to no friction. So the first recommendation I have is hexagonal architecture, right? Organize all of your classes and your components into nice loosely coupled components. There is the whole inbound adapters in hexagonal architecture. So this would be like your REST controller or your Lambda handler, right? Then there's the outbound third-party adapters. Let's say you need to go to property store or you need to get credentials and so on and so forth. So then that you would isolate in an adapter component for that service. Then at the application layer, you would have ports in from those adapters into your application layer. And your application layer is really where all the business logic lives. If you look at this diagram, right there is where you have your if else and who and why. And then instead of doing instead of actually doing the work right there in that method, you then call an adapter or you call your domain layer and different components within your microservice to do the heavy lifting for you. So your domain layer in this hexagonal architecture would include the entities that you own, that you act on. And it would have an inbound port from your application layer to your domain layer. And then it might have an adapter out to, for example, DynamoDB or Aurora Serverless. And then the last directory that I usually like to keep isolated is framework, right? So if you are deploying to a Lambda, you have things that would help you bootstrap that, let's say, microservice to be able to do all your dependency injection, all your logging interceptors specifically for that environment. If you want to move this to a container, you could imagine all the configuration for deploying that microservice would live in this framework package. So now that we've kind of roughly organized our code, let's go into those actual individual classes, right? Those classes should be short. They should be simple, no more than 10, 15 lines tops, right? And they should have very clean interfaces. You don't want a method that has 20 parameters into that method. You want something clean, like, 2 or 3, or use a class that encapsulates all those different 20 inputs. Right? You want to have separation of concern. You don't want to combine your multi-factor authentication with your credential management or some of these other concerns that really are distinct concepts, right? You want to keep that apart. And you want to definitely code for reusability, right? You don't want to have to copy and paste that same code and then find out you have a bug and then now you have to replace it in 30 different places. And most importantly, as you do all of this, you want to have automated tests, right? So that as you add those features, as you build on your serverless microservice to productize the full thing, you're not breaking any of those previous features that you've released. So now that our code is somewhat organized, we know where things go. How do we actually deploy this? Is it going to be a single function for each REST API? So let's say get resource is one Lambda, put resource is another Lambda. Let's say you have another Lambda that does all your event processing. Or on the right-hand side, that lambda-lith, as I've heard some people call it, right? Where it's one Lambda that gets all the REST APIs specifically for one concept, right? So identity credentialing, right? And it handles event processing as well. There's pros and cons to both of this. On the left-hand side with a single function, you could imagine that your deployment artifact is very small. You can see that you might not have as much like stepping on your toes. One engineer can work on put, another on get, and so on and so forth. The lambda-lith lends itself to be able to have more reusable code, more shared code without having to do some of the heavy lifting with like lambda layers and some of the other technologies to share code. It really is at the end of the day up to you how you decide to approach it. Personally, I lean more towards lambda-lith and having a lot more reusability and having a lambda contain all the concept for multi-factor, for example, or all the concepts around username and password. So now that your code is organized, let's talk about security and how you protect that application that you've deployed. So security on serverless, so specifically Lambda. At the end of the day, you want to ensure least privilege. That Lambda should only be able to access what it definitely needs. And it should only be able to be invoked by the specific people, services, or things that should be allowed to invoke it. You want to use reserved concurrency. Reserved concurrency basically means that if you're processing a queue and somebody suddenly puts 1 million requests onto objects onto that queue, you don't want to spin off 1 million Lambdas and then starve any other Lambdas in your account, right? And so having that reserved concurrency says that it's not going to go over, let's say, 100 concurrent Lambdas in a given second. Also, if you need to ensure processing and ensure that every request that it gets resolved, addressed, and stored, then you want to use a dead letter queue. And that would help you then go back and then reprocess any requests on that dead letter queue. In your code, you also want to make sure that any secrets, you're not putting that in code. I mean, I hope you're not doing that. I personally will neither confirm or deny. I might have done it once or twice. But at the end of the day, you want to make sure that that's in KMS or in some sort of service that secures those secrets and that somebody else couldn't get a hold of them. And lastly, especially around REST API and inputs, you want to make sure that you validate those inputs. You don't trust whatever some external party has sent you. Now, for security on API Gateway, there's a lot of different things. And I want to pause and say that some of this might not make sense to you right now. As you're building an MVP, you're always going to keep building and learning and implementing new things, right? So some of these things might be a little bit advanced, but I'll glaze over them. Definitely look up. I'm sure there's quite a few talks that will talk about these technologies over reInvent. But the first things first, right? You want to be able to make sure that you're not going to have millions of requests come to your microservice in a given second, right? You want to throttle your requests into your API gateway. You also want to make sure that if your microservice has private information, that you use authorization. So whether you use Cognito to protect your APIs, a Lambda authorizer to protect those APIs, something there to make sure that whoever is calling you is actually allowed to call your microservice. You want to use resource policies as well to limit access to your microservices. CORS origin resource sharing also has to do with, for example, a website. Can they call any website call your REST API, or does your REST APIs should only be served through, yahoo.com or some other domain name? And most importantly, AWS WAF is another way to protect input. So it recognizes different patterns coming into your API gateway. And if it's, trying to upload an exe file or something of a nefarious nature, then it stops it there. It doesn't even get to API gateway. And of course, it doesn't get to your microservice. So we cleaned up our code. We made sure that it is secure. We know how we're going to deploy it in what infrastructure. Now, how do you actually do those steps of deployment? Deploying your application is, I think, the best thing that you should do, whether you did it in the first rev or not, is go back and use infrastructure as code. I will confirm that I definitely did cut corners when I worked on that identity microservice. And there were a few features that I did go into the console, make a few changes in production, had somebody from our operations team make some other changes for me. And it made it difficult to go back and then use infrastructure as code to be able to automate that. So if you could do that, you definitely want to do that as soon as possible. There's many different benefits, but at a high level, cost, right? So you're replacing those manual steps that somebody has to do with an automated process. And it's also faster, right? It's a click of a button into whether it's a CI/CD pipeline or something to that effect. It's quick, right? And you don't have to wait for a person for manual intervention. And then there's also risk, right? So I had to make those changes in a dev environment, a stage environment, and production. I could have done it perfectly in test, done it well in stage, and then in production forgot one flag, and all of a sudden there is a bug in production, right? So having infrastructure as code makes sure that you have a repeatable process and not introducing risk. There's many tools that you can do this, AWS SAM or AWS CDK, CloudFormation, Terraform, and the list goes on and on and on. So in the previous slide, I talked about this a little bit, right? There's CI/CD, continuous integration and continuous deployment. And so the thought process here is that every little change that you make, you're pushing it to, Git or GitHub or GitLab or whatever your flavor of choice is for version control. And here, one of the patterns, if you look at this chart, is the thought is that each developer works in their own branch and they push changes. Those changes go through integration tests, unit tests, performance tests, etc., and make sure that what you changed has not caused a regression and it's fully functional. And if it passes, and only if it passes, then you're allowed to merge it into the main branch. And that allows engineers to move faster and not have to wait until Joe Schmo fixed the one semicolon that he forgot to add. So we deployed, we have an automated process to do all of that. How do you now look at that infrastructure and decide, okay, I need to optimize my Lambda's memory, or I need to optimize different levers to be able to make sure that it is performant for my end users and I'm also not breaking the bank. So for Lambda, you want to come up with an automated way to both record and replay requests. I've worked on different projects where we had a hook that would take a request, throw it onto S3, and then come up with an automated script that would take that object in S3 and then replay it against the stage environment. And that allowed us to fine tune, let's say in that case it was EC2 instances, but in the case of Lambda, say, okay, do I need to increase my memory or decrease my memory? Should I change my architecture to ARM? So on and so forth. So Alex Casalboni has a library called AWS Lambda Power Tuning, which is pretty cool. You see the chart here. It allows you to use a state machine to change your Lambda's configurations, increase that memory, and then peg it with a bunch of requests, and then pay attention to that duration and see, okay, I've cut the duration in half, but now my cost is X or Y, and find out which memory is actually the right configuration for your microservice. So you have everything in production and you get a bug and everybody is freaking out and you don't know what to do. This is where observability is going to be really important. So as you build this MVP, you're building something that's new. You don't know how it's going to work out. You've planned, you've done all of these different things, but things can still go wrong. How do you figure out what's going on? So Charity Majors has this quote where observability is for running and understanding your code, the code that you write and change and ship every single day, the code that solves your core business problems. And that's really important to be able to understand that. The first thing you definitely need to have is some level of logging. You have to have enough information to at least be able to create a red dashboard. A red dashboard is R for the rate of requests, E for errors, and then D for duration or delay, right? And quickly you should be able to identify, okay, there's a problem, I made a change, and suddenly instead of taking 200 milliseconds, it's 500 milliseconds, and so on and so forth. Or there's suddenly a spike of errors, and then you can quickly swarm and solve that problem. You want your logging to be centralized, to be able to easily do a quick search and see the user's traffic through your system and be able to correlate one microservice call maybe to another microservice. And there are a lot of tools to do that, whether it's in CloudWatch, Splunk, Datadog, New Relic, etc. There's also the concept of tracing. And so, for example, AWS X-Ray has the ability where you can see the data coming into your microservice, and as it goes to different services, be able to see the duration of those different service calls to see if there's a problem on each one of those different nodes. It also has the ability to add metadata so that you can slice and dice your information, and you can realize that, oh, when a user that has this use case is hitting my microservice, they're constantly running into this problem. And then identify and be able to quickly change those issues. So now you've done all of that, but then the worst happens. Something happens, API gateway is not working, or your microservice, you've done something and you hosed your application and so on and so forth. What do you do, right? What happens when your application is down? First, you need to define your SLAs, right? What is that recovery time objective? Like, I have 4 hours to be able to get this microservice back up and running. Or, you know what, maybe I'm comfortable with waiting a day or waiting 48 hours, so on and so forth. You have to figure out what your tolerance is for that microservice. And then there's also this concept of recovery point objective. So I waited 4 hours and I can recover to my state 1 hour ago or one day ago. Or, this microservice is so key to my business, I really can't lose more than 5 minutes of data. And then once you have defined those two tidbits, then you can start planning, okay, what is my disaster recovery policy? Am I going to always deploy to a separate region or some other DR site so that if something happens, I can roll back? Am I going to back up my data to S3 in one region and another region? There's a lot of different levers to be able to handle with disaster recovery that you just have to walk through and decide for your productized MVP, what is that going to be? So we're now going to take a look at a microservice that I've created. We're going to go into the little nuances here and there so that you can kind of see why I made the decisions that I made and how that might help you in your MVP and being able to grow that MVP seamlessly. All right, so let us look at some code. So here we have a serverless event microservice, and this is a Java application that basically fronts events or sessions at reInvent, for example. And it has the description of the event, the date and time, and then finally the ID of that event. And this microservice has a REST layer to front that data. So if you want to get all the events or if you want to get the details about a specific event, there's an API that hits this microservice to get you that information. So we're going to look at some of the things that this microservice has that we've talked about, right? And so if we pop over here in our main Java directory, you can see roughly the application is broken up into different packages, into different directories. So we have an API directory, which is our inbound adapters using the terminology from hexagonal architecture. Here we have our DTO objects, data transfer objects. So here's that event, description, date, ID, nothing complicated here. Then we have our inbound Lambda handler. So our Lambda handler, if you take a look, is very simple. The first Lambda handler that I wrote for this microservice, and probably for yours as well, was a very long handler that had all the guts and glory and details in this method. Adopting principles around hexagonal architecture, that is no longer the case, and we're delegating that to different classes and different services throughout our application, again, to leverage that loose coupling. So I'm using Spring Boot here, and so with Spring Boot, it will automatically take that input stream from API Gateway's proxy request, and then that will convert that input into an HTTP request object, right? And so that then gets routed to our events controller. And so in our events controller, again, you'll notice we don't have this long get events function that has all these different steps and tasks. We've now moved that heavy lifting, that work, into a service layer. And so our service layer, you can imagine, is where that business logic lives. So if we pop in here, we look at, again, using another terminology from hexagonal architecture, this is our port, our inbound port into our application service layer, right? And the implementation, you imagine with hexagonal architecture, I can switch this tomorrow. And instead of, implementing it with this service simple, I could implement it with a specific, instead of reInvent, let's say it's AWS Summit, for example. And it would have slightly different business logic. So if we look at one of the methods here, again, you will see very simple. The methods aren't too long. There isn't a long list of parameters. If we read through this, we really quickly can tell what's going on. First thing, it's validating our input. Second thing it's doing, it's calling our repository to get an actual entity and get what the person asked for, right, by that ID. Once we get that event ID, we then map that entity into a data transfer object. And again, we do this to have that loose coupling. Tomorrow, you can imagine that event entity in DynamoDB or AWS serverless or in Aurora, for example, that could look quite different. And we don't want to break that contract that we have with our front end applications. So here we have that converted into a data transfer object and then bubbles right back up into our API gateway response. I'm going to jump into the repository service. Again, you might be recognizing a pattern here. Our methods are very lean. There isn't too much going on here. But you could imagine into this port, for example, inbound port into our domain layer, I could have a flag here that says, okay, which database am I using? Am I using DynamoDB or am I using Aurora Serverless? And based off of that flag, you can imagine a world where we can migrate and build on this microservice and productize it flexibly without affecting any of the upstream callers. There needs to be little to no refactoring outside of this domain layer. Another thing that I mentioned earlier is testability, right? Having these really short methods, being able to assert one little detail here and there also is an advantage, right? You don't have to have that really long cognitive overload to be able to understand what this one method does, right? And very quickly you can see, okay, I can mock my repository call. I then actually call my subject under test. I assert the response that came back, and then I make sure that all the details that are in that class are what I expected and that it actually did call my repo. So it's not returning stub data or anything. It actually went and made the effort to call a repository. Again, talking about refactoring, right? When I mentioned switching out the database, you could imagine a world where in that mocking area, you say that the property is Aurora serverless is set to true, right? And then you would verify that it didn't call your DynamoDB repository and instead called your Aurora serverless repository. And again, building in flexibility from the ground up. So now that we've looked at the code, so let's switch over to our pipeline. So here you can look at, I have GitHub set up for my project. I use Sam's CLI's ability to create a pipeline for GitHub Actions. And so we take a quick look here and you can see, okay, I was working in this branch. I messed it up royally as I was refactoring. I then went and fixed all the mistakes I made. I made a couple minor changes here and there. And then, and only then, did that change get merged into main. And so you can imagine, again, a world where you have multiple engineers productizing this microservice without stepping on each other's toes and ending up in what we all know and hate of GitHub merge hell, right? And so we can take a quick look at this pull request and you can see, for example, the different steps that happened. So with this commit, I broke it and we could click in it, look at the diff. You can imagine folks could comment on it and say, Yvonne, what were you thinking? Why did you do that? Right? And then you see, okay, I fixed it, I pushed it, then I did a bunch of different refactoring here and there, and then pushed it, and then everything's nice, beautiful, and great. And then it was merged into production. So that is our pipeline. Let us switch over now to look at power tuning, right? Once we have decided what our application looks like, and we've set up our CI/CD pipeline, we have it running. You can imagine engineers are hitting it in your test environment or your stage environments. Now, did we choose the right settings? So I'm going to go here and run our power tuning. Let me show you that config for that. So if we go open, scripts, sample, here we go. So the way you config AWS Lambda power tuning, there's an input file. You say what your Lambda ARN is. You say what memory settings do you want it to test out? How many requests do you want to make? And then you give it array of requests, what that payload might look like, the probability that it will use this payload versus one of the other ones. And then all we really have to do is click on Bash scripts execute. And this is going to take a few minutes. I'm going to leave this running and we're going to go and take a look at our dashboards. All right, so here's my dashboard. We've been doing this power tuning bit now, so it's making requests. We can refresh this and the numbers might change here and there. So if you look at the top layer, this is the red for Lambda, right? So these are the requests that Lambda got, the errors that Lambda had, and the duration that it had, right? And in terms of invocations versus API Gateway, you might be saying, wait, why are there half a thousand invocations to Lambda and not through API Gateway? The reason why that is the power tuning goes directly to the Lambda. It doesn't go through API Gateway. So these 51 that you see are ones that I've done before this talk, clicking and refreshing so that we could get some numbers here. And you can see, okay, there were 2,400 errors, and very quickly you can react on this new microservice that you've published, right? And you can see 400 or 500 errors, which really shouldn't happen. So those might be clues that something is going on. And so this red dashboard, again, the point is to give you actionable data to say, okay, everything is good, everything looks fine. I can move on with my life, or, I have issues. Let me fix that before I go and work on my new feature. All right, so our power tuning run has completed. I'm going to click on this link here. And so you can kind of see, wow, look at this loop, right? It gives you an idea of like, okay, how long did that request take to process as we increase memory? And how much did it cost me at those different memory points, right? And so the best cost is at 512, right? And the best time for our end users is at 300. So you can kind of take an educated guess and say, okay, let me put it at this. If we had blindly done that, maybe my first knee-jerk reaction would be like, oh, let me raise it to 1 gig or a gig and a half or 2 gigs or whatever. And you would have seen that we would have been worse off in terms of cost if I had done that, and not that much of an improvement for our end users. I actually was able to take this request and then compare it with like ARM architecture. All right, so here's comparing ARM architecture with the x86 architecture. And then again, you kind of get a better idea, okay, which should I really do? Should I use ARM? Should I use x86? And then find that sweet spot for your application. Okay, so the last thing I wanted to show you is our service map. All right, so here's AWS X-Ray. There's obviously a lot of other tools that you can do something similar like this. This really gives you good visibility, though, into the AWS ecosystem, right? So you can see here DynamoDB table, our function, the Lambda service, and you can again see this is where AWS Power Tuning was calling our function directly. And then here's where I was, going in my browser and creating all these different requests for the sake of data. And again, you can quickly identify. So this yellow here is my 400 and 500 errors. And again, this is all about being able to react on your MVP, on the data that it's creating, and be able to make an amazing productized microservice. All right, so I hope you got a good high level of how your microservice could look like, how you can organize your code, and some of the different tools that you can use to be able to productize your MVP. Most importantly, what I want you to come out of this talk is that you're not going to go through these steps, you're going to complete it, and that's it. This is something that you're going to constantly have to be taking a look at. Rinse and repeat. You shouldn't assume that any choice that you made on day one is going to be the same choice that you might make in 6 months or a year and so on. Given that, customer loop, right? They might tell you that, okay, well, I need XYZ, right? So that you might have to change your architecture to be able to support that. Or you might realize that your load is a lot higher and maybe you need to switch out your database from DynamoDB to maybe Aurora Serverless. You should be constantly reevaluating, enhancing, refactoring your microservice. And when you make any of those changes, that you're always designing for flexibility and maintainability. These are some of the books that I have really enjoyed reading that have dictated a lot of the decisions that I have made. Chris Richardson's Microservice Patterns. Joost Visser has this Building Maintainable Software, which is a really thin book. I mean, I was able to get through it within one, well, maybe a day or two, but it's a lot shorter than the other two books and has a lot of valuable, actionable data. Sam Newman's Monolith to Microservices is also a big key on how you take a big monolithic microservice, not monolithic microservice, monolithic application, break it down into microservice and decide what are those MVP stages from when you get from that first step to that fully productized application. As always, you can follow me on Twitter, IVLO11 on Twitter. And then my website is YvonneRoberts.com. I also have a YouTube channel, Serverless Dev Widgets, where I like to drop a lot of little tidbits. Some of the things that we talked about are there already. If you would like the slides and additional content around this talk, please visit this link, YvonneRoberts.com/serverless-MVP. Thank you very much for spending this time with me. I hope that you've learned something new and that you always keep building and, most importantly, happy coding.